Hello friends, welcome back to Edupedia Word Videos, your destination to free online education. In this video, we'll be learning or deriving some trigonometric identities. Friends, first of all, we should know what an identity actually means. Friends, a rough definition says that an equation which is applicable for every value or every real value is an identity. Say, earlier we have studied the algebraical identities as a plus b whole square equals a square plus b square plus 2ab. Now, whatever value you put for a, say 1 or 2, etc., 3, 4, and similarly for b, this equation will always hold true. So this is an identity. On the other hand, say x plus y equals 1. This equation is not always true. Now, say put x equal to 1 and y equal to minus 1. Then left hand side becomes 0 and right hand side will become 1. So this equation will fail. If you put x equal to 1 and y equal to 0, or x equal to 0 and y equal to 1, we will have LHS as 1 in both the cases. And RHS is always 1. So this particular equation is not always true. Hence it is not an identity. Whereas this is a formula, that is, this equation is always true. So this, my friends, is an identity. So we'll be deriving similar identities in case of trigonometric word. So let us start by first having a triangle. Say we have a triangle ABC right angled at B, that is a right triangle ABC right angled at B. Then Pythagoras theorem will be applicable. Now by Pythagoras theorem we have perpendicular square plus base square equals hypotenuse square. Here perpendicular is AB, base is BC, and hypotenuse is AC. So by Pythagoras theorem we have AB whole square plus BC whole square equals AC whole square. We'll be using this particular equation, the theorem, in three different ways to derive some identities. But first of all, let us find out what are the values of sine, cos, or different trigonometric ratios here. Friends, if C is the point of interest, say this angle be theta, because theta is the most common term used for representing angles in case of trigonometric ratios in the world of trigonometry. So sine theta or sine C, one and the same thing, is perpendicular over hypotenuse, that is AB over AC. Cos theta is base over hypotenuse, that is BC over AC, and tangent or tan of theta is perpendicular over base, that is AB over BC. Similarly, their reciprocal counterparts, that is cosecant of theta, will be this reciprocal, that is h over p, or simply AC over AB. Secant theta will be similarly AC over BC, and cotangent theta will be the reciprocal of tangent theta, that is BC over AB. Now just write this Pythagoras theorem applied to this triangle. The first case will become AB square plus BC square, or rather whole square, equals AC whole square. Divide both the sides by AC whole square. What we get? We get AB whole square over AC whole square plus BC whole square over AC whole square equals AC whole square over AC whole square. So these are one and the same thing, so these get cancelled in right hand side, and we are left with AB over AC whole square plus BC over AC whole square equals 1. Now friends, what is AB over AC? It is sine of theta. And what is BC over AC? It is cos of theta. So in left hand side we have sine theta and cos theta with their respective whole square. That is sine theta whole square plus cos theta whole square equals 1. Now we have studied in the video titled Some Points on Trigonometric Ratios that this square, that is sine square theta, is nothing but sine theta whole square, and vice versa. So this square comes over here. On solving, we get sine square theta plus cos square theta equals 1. Friends, this is the first trigonometric identity of our course. Let us again rewrite this Pythagoras theorem applied to this given right angle triangle ABC, right angled at B. Now divide both the sides by, say, BC whole square. Earlier we have divided by AC whole square. Now we are dividing by BC whole square. In the next step we will be dividing by AB whole square. So we get AB whole square over BC whole square plus BC whole square over BC whole square equals AC whole square over BC whole square. So this becomes AB over AC whole square plus 1, because both the things on numerator and denominator gets cancelled, and AC over BC whole square. Now friends, what is AB over AC? Sorry, here it is BC, because we have divided by BC. So what is AB over BC? Clearly look here, it is tangent theta. So this part has become tangent theta whole square, or simply move square inside and we have tangent square theta plus 1 equals AC over BC. Now AC over BC is from here secant square theta. So both the terms, that is tangent theta and secant theta, are involved in this. So as a whole it is secant square theta, or simply this term. So friends, this is the second identity. For making it symmetrical to the first identity, let us separate 1 and move the other terms to the other side. That is 1 at left hand side and secant square theta minus tangent square theta on right hand side, or the identity has become secant square theta minus tangent square theta equals 1. So friends, this is the second identity. So the two identities are sine square theta plus cos square theta equals 1 and secant square theta plus minus tangent square theta equals 1. Let us do another task. Now it is, I think, clear what we will be doing in this particular case. We have divided by AC whole square in the first part, dividing both sides by AC whole square. In the second part we have divided by BC whole square. So in the third part, just divide both sides by AB whole square. So we get AB whole square over AB whole square plus BC whole square over AB whole square equals AC whole square over AB whole square. So now this AB square cancels this AB square and we are left with 1 plus BC over AB whole square equals AC over AB whole square. Now let us find out what BC over AB and AC over AB are. Friends, BC over AB is cot theta and AC over AB is cosecant theta. So the first part is cot theta, cot square theta, thanks to this 2 over here, and the second part is cosecant square theta. For symmetry, let us move 1 to a separate side and cot square theta to another side, and the equation becomes cosecant square theta minus cot square theta equals 1. So friends, this is the third identity. So all in all, the first identity is sine square theta plus cos square theta equals 1. The second identity is secant square theta minus tangent square theta equals 1. And the third identity is cosecant square theta minus cot square theta equals 1. Friends, these identities, once remembered, will help you in solving almost all the problems of trigonometry. So friends, these were identities of your course. Thanks for watching Edupedia Word videos.